Hello everyone, and today we will be seeing sort colors. This is one of the famous problems, and it says given an array containing 0, 1s and 2s, you need to sort it out and you need to do it within the place. Within a place it means you do not need to create any resultant array as such, or no need, and you directly need to go ahead and work upon the same data structure. In this case, within the same array. So let's get started. So within this we'll be talking about few approaches over here, each from increasing order of its efficiency. And within the meantime, we will be also seeing what all hurdles, what all the back steps which will be required. So this is a basic problem within the understanding of array as a data structure and operations of a sort as an algorithm upon the data structure. Here we will be starting with the basics and crawl our way up with finding multiple constraints, hurdles, or bottlenecks within our algorithm. So let's get started. Approach 1. So approach 1 is nothing but you have an array and you need to sort it. Just that's it. This you can do it also by adding the few constraints upon this, a few type checking, which is always good to have. So let's submit this. So it says accepted, but the time complexity is still based upon the sorting algorithm. What all hurdle? One obvious way is to use known sorting techniques as a selection sort or merge sort or quick sort. So the coding goes over here. Simplest, but no one wants it. As in such cases, we have making no use of the fact that we are having only three elements, that is 0, 1 and 2. Instead, we treat every number as a plain integer and sort it. So this is a wastage of the information, and maybe we can do it better. Let's go to approach 2, and maybe we can do better. How? Let's check it out. So approach 2 is nothing but a hashing solution. So in this one is slightly better. Here we are taking into account how many times we have encountered zeros, ones and twos. Once that is known by basic number system, we all know that 0 occurs before 1 and 1 occurs before 2. In such a way, we fill up the array as per the numbers, number of zeros, then ones, and then twos. So let's go to this one. So as usual, we will have our first check whether the array is null or it's an empty. Then we throw an exception, else we go with our solution and we'll have a count table which will store a count of three numbers, which is 0, 1 and 2. Pretty self-explanatory, isn't it? Then we have a mechanism to populate the count table. Next to it comes the iteration of our elements. Here we will need to have look for three contents, that is 0, 1 and 2. So we can have three if statements if we have 0, if we have 1, if we have 2, but the better way is to use a loop, and we can get one by one elements and we can have a value. So now I'm having over here is content, and the content of array is nothing but the items which the array stores, which is nothing but 0, 1 and 2, and we'll have a count table, and the count table will show us the content. If the content is greater than 1, so we have a inventory store of the content. So we just use the inventory, we populate the array with that content, and ultimately we reduce the inventory count. Since we have utilized this, we need to reduce the count. And we do not need to run over the other contents because we found a content and we break the loop from the inner loop and we go for the next I element. Till this point, when the loop ends, we are sure that array is sorted. And just submit it to check it once. So well, it's submitted with accepted result, but still, uh, this too have few problems. What if the count which we are taking into consideration is out of bound from the integer limit? One can argue that in such cases we can take long value into consideration, but still the limit hits then. Big integer? Mm, but this doesn't solve our problem. This in fact slows the system and makes it more prone to errors as the size of array increases. And also the second problem is, what if the input is non-static data? It's not a static data but a stream of data. In such cases, the input values will continue to come and not stop. In such cases, our algorithm would halt upon the counting itself. In such cases, our algorithm will halt at a counting step itself and not move forward, hence not making the in-place streaming content sorted. 3. Stay tuned for solution of this. Approach 3. Upon seeing our above hurdles, we come to know that the approach can be improved and adapted to new circumstances. Hence, we can have the insertion points within the array. These points will indicate where the incoming data could be inserted for zeros, ones, and twos. For any such new upcoming stream data, we need to look that appropriate pointer within 0, 1, and 2 and then insert the upcoming data. So first, as usual, we check for null or empty array. Next, we take three pointers, low, mid, and high. These are for storing the pointer location, the appropriate points to be insertions of 0, 1, and 2 respectively. And life would be much more easier if we have only 0 and 2, isn't it? Just insert from left in case of 0 and just insert from right in case of 2. But with 1, we take mid into consideration and parse the mid from 0, which is assigned initially, to the appropriate location till the point it is valid and does not bump into a high. So for such cases, we take a loop, and for such cases, we loop from mid to high, taking every value into consideration which occurs from mid. We check with the rate is 2, 1, or 0, and then by default we throw an illegal argument exception if we do not encounter any one of them. So let's populate each one. So once we encounter 2, we are sure that mid contains value 2, which needs to be inserted within the higher location. But one thing is that once we insert into the higher location, the probability of losing the high value at a higher location would be high, because we'll be losing the value within the higher location. That is not what we want. So we swap it, and once we swapped it, the value is placed at higher location, longer need value at high. So we decrease the insertion point from high to less. Update the insertion. Next case, what if we found 1? So it's alright to find 1 at this place of midpoint, as this is what we are expecting to get once within mid. And once we get this, we just update the insertion point of mid, and that's it. Update the mid pointer. So what if we got 0 within the midpoint? So here if we see any 0 within the insertion point, we need to increment the pointer of upcoming 0 and place the midpoint 0 within the appropriate position of 0. Remember, 0 should be placed at appropriate position of 0. That's what we are doing. And the best way to place and exchange these elements is to go and swap these elements. So we go ahead, swap these elements, and we update the lower insertion point, that which we need to do, because we have just inserted 0 and we update the mid. Why mid we have updated? Because we need to not stay upon the current location as it is already 0. Why it is 0? Because it has just been swapped from the lower position, which is an appropriate point of mid, which is an appropriate point of getting zeros. So by default, the current mid would have 0, which is not required at all, and we need to have mid plus plus. So this was it. Default we have already handled, and ultimately when we close this, we have a sorted array. Let's submit it to it verified. And definitely this is how our swap method looks like. Let's let's submit this. And yeah, it has accepted. Would it be even fair to talk about this solution and not about any problems within the solution? So in such a way, we have removed hurdles from the approaches for now. This still seems to have a minor issue with the scalability. Like, what if we have 0, 1, and 3 within the digits? In such cases, we need to have multiple pointers for insertion and handling, and multiple pointers for insertion and handling would be complex. Although, if that would take place, then the problem itself would be changed and would not be sort arrays of zeros and